Take out your notebook, please. Your notes, notebook, whatever. I don't want to stand there like awkwardly staring you away from you. Alright, write that down. This is 0.5. So we have done reverse chain rule and we have done definite integrals. So this is like, I think I'm not teaching anything new here really. I'm just going through a couple of examples where they're combined. That's what on the worksheet, just saying it out. And this is the last new material. So today, you'll have time to practice this worksheet and or do your con. Tomorrow, I'll give you a practice gateway. You'll have time to do that and or do your con. And then the gateway is Wednesday, Thursday, Friday, as long as you have the con done before Wednesdays, before the gateway. Right? Good? Okay. Alright, so just remember like what reverse chain rule is. So we got a big guy here and a little guy here. So the big guy's the half power, the little guy is 2x plus 3. So we'd sometimes go, okay, L equals 2x plus 3. What's L prime? Well, it'll probably be 2, right? So you would need there to be a 2 on the inside here, which would make you put 1 on the outside. 1/2. And then when you integrate, this 2 ends up going away. The point isn't really the 2 itself, the point is the 1/2 out there. And then I'm going to leave that 1/2 outside. I'm going to leave the 0.5 and the 3. And I'm going to integrate the big guy. So the big guy was the power. How do I integrate powers? Add 1 and multiply by the reciprocal. I mean, nothing new there, right? Yes, you remember this? Yeah. Okay. And then you just plug in. So, I mean, we did up until that before. We've done the plugging in before. I'm just putting them together. So then it would be 1/2 times 2/3 times 2 plus 2 times 3 plus 3 to the 3/2 minus plug in the 0.5. Big mess there. And you got those fractional exponents, which I know you guys are super fond of. You see what I'm doing though? Just plugging the top minus plugging the bottom. And then if I work through this, I got 1/2 times 2/3 times, okay, well, what's this? What's 2 times 3? 6 plus 3 is 9, and then you got this root power thing up here. So remember the bottom goes first, so you take the second root of 9, and the square root of 9, which is 3, and you take that to the third power, so 27. I got the same thing going on over here, so 1/2 times 2/3 times, okay, well, what's 2 times 0.5? 1. 1 plus 3 is 4. And then what's the second root of 4? 2. 2 to the third is 8. fractions, just go straight across the top, straight across the bottom. So this will be 54 over 6 minus 16 over 6. So 38 over 6, which you could leave, or you could make that 19/3 if you want. But like nothing new there, just kind of combining it to make it a little extra fun for you. Questions on that one anywhere? I'll leave it up for a second because some people are still taking photos, like paparazzi. Let's try like a easy one. Try that one. Let's try this. Write it down and we'll do it together. So, what's the big guy? E, little guy is the 2x minus 1, right? So what's the derivative of the little guy? 2. So your L is your 2x minus 1. Your L prime would be 2. And so I need this 4 to be a 2. So I'm going to multiply the inside by a half, which means I multiply the outside by 2. And then this is the derivative of the little guy, and it just goes away. And you want to integrate the big guy. Well, what's the integral of e to the whatever? It's e to the whatever. So I just have 2 out here, e to the whatever in here, and then a 2 in the 5. So last time, I'm just going to show you kind of options here. We had that 1/2 on the outside, and I put it in both spots. I could have just as easily left the 1/2 on the outside and waited until I was done with everything else and then put it back in. So I'll do that this time so you can kind of see both options. So I'm just going to leave this 2 over here. And then I'm going to go e to the, this would be e to the 9th, right? It's 2x minus 1 minus e to the 3rd. That's your answer. You can't combine those. So if you want to distribute and say, like, okay, that's 2e to the 9th minus 2e to the 3rd, you got it. I was expecting more to happen after that. So either of those are acceptable answers. Questions on that one? Seem okay? Same steps before, just combining, right? Yeah. So could you do like x to the 5th minus x squared? So here, let me go through this like as a general thing. So when I was in, I don't know, high school math, I would have the same question, like why didn't you do that? And then, but I never remembered the rules. Like there's all these rules like when you're multiplying, you add powers, when you're dividing, subtract powers, right? But it's hard to keep track of what's what. So you can always test them. So like if you think e to the 9th minus e to the 3rd can become e to the 6th, well let's test it with like numbers that we know that's true. Or the numbers that we know and see if it's true. So if this is true, wouldn't it make sense that this would be true? I'm not saying it is. I'm just saying, wouldn't that be like something I can test? Let's plug in like 2. What's 2 to the 5th minus 2 squared, and does that equal 2 to the 3rd? So there's a question mark there. Well, what's 2 to the 5th? 32. What's 2 squared? 4. What's 2 to the 3rd? 8. So does that rule work? No. This is how I got through high school math. I would just like test stuff. Because I could never remember those rules, so I'll just try them. So when this doesn't work, then this doesn't work, and then I'm just going to stop. Is that decent enough? Yes. So I think you're thinking of, yeah, I don't know. I'm not sure why I don't want to like guess what you're thinking of. But other questions on that? Let's try L1 one. Don't try it. First person to talk gets their way.
Let's try it.
Try it. Alright, so what's the big guy? Yeah, so how would we write this, right? So like x plus 4 to the negative 1 power. Negative 1's your big guy, what's the little guy? Not even reverse chain rule, is it? So I would need a 1 there. There is a 1 there already. So I don't need to worry about anything. But the only thing that reverse chain rule does is we might put a number there and a number there. Like that's the new material that I'm going through. So to add 1 to the power, get 0, multiply by the reciprocal, but that doesn't work out. So it's ln of x plus 4 from 1 to 6. So it's the ln of 6 plus 4 minus ln of 1 plus 4. So ln of 10 minus ln of 5, which reduces to be ln of what? 2. Should I go through those rules again? So whether it's odd logs or ln's, they're the same. But if I have like ln of a minus ln of b, that's ln of a over b. Subtraction combines to be division. I have ln of a plus ln of b. That's multiplication. Or if you have like ln of b to the n power, you could rewrite it with the n in front. So this kind of works either way, depending on how the simplification is working. Questions there? Okay. The worksheet you have in front of you, I want you to go through and cross a couple of them out. Cross out number 3. So everybody have the worksheet? Cross out 3, cross out 5, $14, $15. So we got 3, 5, 14, 15. That's it. 3, 5, 14, 15. The rest of them you should practice, or you should know how to do. You know, if you can work on these right now. You can work on your con right now and ask for help on that. I gave you guys a list of like what's going to be on the gateway, right?
Yeah.
So you gotta know how many of each type. Does anybody need that? Was anybody not here when I gave that out? time to do whatever calculus you would like to do.